This lesson is covering difference of squares pattern. So with binomials, to look at what the difference of squares pattern, if I were to FOIL, so multiply in the specific pattern, first times the first, outside terms the outside, inside two terms, and the last two terms, it's going to have a specific pattern for difference of squares. So if I multiply the first term times the first term, so x times x, I end up with x squared. If I multiply the outside two terms using FOIL method, so outside times the outside, x times a minus 4 would be a minus 4x. And then 4 times x for the inside two terms would be a plus 4x. And then 4 times a minus 4 would give us a minus 16. After combining these two terms, we end up with x squared and then a minus 4x plus 4x. These two cancel out. They're opposites. And we're left with x squared minus 16. So we've got x squared minus 16. We're showing subtraction and then two perfect squares. That is showing us that difference of squares pattern where that first term is a perfect square. We have difference or subtraction between the two terms, and the last term is a perfect square. So that's the way to identify if it's a difference of squares pattern, is if you're subtracting two perfect squares. So to compare if something is difference of squares pattern, we want to look to determine if that first term and that second term are both perfect squares and it has subtraction. So z squared. That is a perfect square because z times z is z squared. So that's a perfect square because it would be z times z. 36 is a perfect square because you would have 6 squared. And then it is subtraction, showing the difference. So yes, this one is showing difference of squares pattern where I'm subtracting two perfect squares. Another example, I have w squared plus 49. Our first term, w squared, is a perfect square. Our second term, 49, is a perfect square, but this one is not subtraction. This one is addition. So no, this one is not difference of squares. Think of the word difference, meaning subtraction. This example, I have 9x cubed minus 16. Well, 9 is a perfect square and 16 is a perfect square. I'm showing subtraction, but because this is x cubed, there's no way to multiply a number by itself and have it equal an odd exponent like that, have it equal x cubed. So this one is no. If my exponent was an even number, then it would be yes. So for example, if this was 9x to the 4th minus 16, then it would be yes, because x to the 4th is a perfect square. X to the 4th is equal to x squared times x squared. So as long as your exponent is even, it can show, and your coefficients are perfect squares, then it could be a difference of squares pattern. But odd exponents will not work. There's no way to multiply an odd or an exponent by itself and have it equal an odd exponent. Another example, if this was x to the 12th, for example, since it's an even exponent, this is the same as x to the 6th times x to the 6th, so it would be a perfect square for that one. And one last example, 1 minus c squared. Now this one, though it's in a different order, we can still look at it. So is 1 a perfect square? Can I multiply something by itself and have it equal 1? Yes. I could multiply 1 times 1. So this first number 1 is a perfect square. I'm showing subtraction, so that works out. And then c squared, I could multiply c times c and have it equal c squared. So this one is yes, this one is showing difference of squares pattern.